Excuse me, sir. You are muted.
Thank you. I thought I was. I thought that you could hear me, right? Sorry. So again, good evening to all of you. And first thing is, since you have gone through the recordings, I hope that you went through the recordings, and there we discussed how to convert this, right? We discussed already how to convert from binary to decimal, and also so mainly what we discussed was decimal to binary, and also you should be able to convert it again back and forth, right, between these two number systems. May number systems දෙක අතරේ අපි මේක පරිවර්තනය කරගන්න දැනගන්න ඕනේ. That is one skill that you have to obtain. ඒක එක නිපුණතාවය. So that's the one skill that you should be getting. Right now, next we come to do one exercise to just see if you can do it properly. So I will give a number which you can convert and see the value that you get. So try to convert this now, since you are familiar of converting decimal to binary, now we will do the other way around. So convert this number to decimal, right? Convert this to decimal and see what is the output that you get. Okay, take some time and convert. Finished?
Clear writing, sir.
Okay. After you finish, tell me the answer that you got. What's the value? Finished or not yet?
Not yet, sir.
Right. Complete it. Once you finish, tell me the answer.
Sir,
Yes.
I didn't quite understand how to answer this
Right.
question.
Okay. So any others? Amindi, did you get the answer?
Fair writing, sir.
Okay. Let's see. Now I just want the answer from at least one of your students. Pranidhi.
Still writing, sir.
Okay.
Done, sir.
Done. Okay. Tell me the answer.
158.
115.
58.
You mean this? Is it the answer?
158.
158. Is that the answer?
Yes, sir.
Okay. Others? 58 or 68? Is it correct? Okay. So that's Amindi's answer. And Pranidhi?
168, sir.
168, right? So that is Pranidhi's answer. So we'll see. Now you should observe how to do this one. මේක කරන හැටි දැන් හොඳට බලන් ඉන්න ඕනේ. So we'll write it down. 1 0 1 0 1 0 0 0. That's it. You should remember we have the place values for each bit in this bit pattern or in this binary number. So each place has a place value. So we'll write down the place values of each location. So the place value of this is going to be always, now this is a base 2 number. So place value of this is 2 to the power 0. Place value of this is 2 to the power 1. This is 2 to the power 2. 2 to the power 3. 2 to the power 4. 2 to the power 5. 2 to the power 6. 2 to the power 7. Those are called place values. Now, if you take these place values, what is the value of 2 to the power 0? Yes. So I actually gave these things last time. Can you look at the note and tell me? Now, maybe do not note
1.
1. Good. So any numbers 2 to the power 0 is going to go. Any numbers power 0 is going to be 0. So it's going to be 1. Then 2 to the power 1, 2, 2 to the power 2, 4, 2 to the power 3, 8, 2 to the power 4, 16, 2 to the power 5. Tell me, what is this?
32.
32. 2 to the power 6,
64.
64. 2 to the power 7,
120.
120. Once you have these values, then මේ values ටික දැක්කම මේ විදිහට මේක අපි ලියාගෙන, so once you have these values, you can now do the calculation by following this method. So now again observe this. First, we have this 2 to the power 0. So you have to take this place value and multiply it by this value. So the place value is going to be, so this is the place value. This 0 is taken from here. Then you have to add it to 2 to the power 1 multiplied by 0 again. So this 2 is taken from 2 to the power 1 is taken from here. This 0 is taken from here. Again, plus 2 to the power 2 multiplied by 0. Again, you take this 0 from here, this from here. Again, we take plus 2 to the power 3 by 1. Then we have this 2 to the power 3 here, 1 here. Now, you should understand that how we are doing this. So here we have 2 to the power 4 by 0, 2 to the power 5 by 1, 2 to the power 6 by 0, 2 to the power 7 by 1. So now you have to simplify this. 2 to the power 7, that value is going to be 128. So we can write 128 multiplied by 1. 2 to the power 6 is going to be 64. When you multiply any value by 0, what is the value that you get? One value of 0 value.
0.
0. So we can put 0 here straight away. 2 to the power 5 is going to be 32. So 32 multiplied by 1. 2 to the power 0 is going to be against 2 to the power 4 is going to be 16, but we multiply it by 0, so it is going to be 0. 2 to the power 3 is going to be 8. Then you multiply it by 1. So 2 to the power 2 is going to be 4. You multiply it by 0, so you get 0. This is also going to be 0, and this is also going to be 0. So we have the values here 128. This is 0. This is again C32. 8, 0, 0, 0. Then ultimately we get 128 plus 32 plus 8. And you can see this is 40, and 40 plus 120 is going to be 168. So Pranidhi gave the correct answer, so good. And now you can fix it. So if you, now did you understand how to do it? Deandra, did you understand how to do it?
Yes, sir. Thank you.
Okay, now do it and see if you can manage to do it.
Done, sir.
Right.
Done, sir.
Okay, so I hope you understood the way to do it. Right, since you made it wrong, so we have to find out how to make a value in the current thing because of that one. So we do another one. So only Pranidhi did it right. So you have to find out how to do another one and see that you can manage to do it. So do this conversion. One. Do this. And tell me the answer.
Done, sir.
Right. Okay. Who finished? Pranidhi,
Yes, sir.
tell me your answer.
188.
188. Okay. Others complete the calculation.
Done, sir.
Okay. What is your value?
188.
Okay. I mean, these all the same. Yeah.
Sir, I got 188.
Okay. Now show me your books. Turn on the cameras and show me your books. So I just need to see the way you have done it. I mean, wait. I will have to check one by. Okay. So good. And then Pranidhi.
Sir, give me a minute.
Okay. Yeah, you can show the book.
Sir, give me a minute.
Okay. Right. Okay, good. And Diane, you have to show me the way you have done it.
Sir, give me a second, sir.
Okay.
Sir, I have done something wrong, sir. Can you give me a second, sir? I'm fixing it.
Okay.
Sir,
Yes.
sir, for the question you gave, sir, I'm still a little confused how, like,
Okay, so we'll do it then, right? So what we have to do is now you have to actually do it by yourself somehow. So for the moment, I will explain you again. You should be writing it. So you can see here the number. So again, listen to me. So you have to write it with some spaces between these. So you can say 1, then 0, then again 1, again 1, 1, 1, again 0, 0 is the number. So I told you each location has a place value. So this location is having place value 2 to the power 0. So you multiply it by 0 plus 2 to the power 1 multiplied by 0 plus 2 to the
excuse
power.
me, sir.
Yes.
I can't see the whiteboard screen.
Okay, I hope you can see now. So 2 to the power 2 multiplied by 1, 2 to the power 3 multiplied by 1, 2 to the power 4 multiplied by 1, 2 to the power 5 multiplied by 1, 2 to the power 6 multiplied by 0, 2 to the power 7 multiplied by 1. So the technique that I explained you, so always the zeros are going to be the one that you multiply the power of 2, which is relevant for each position, right? And this number is taken from the actual position. So this place is actually 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. එතකොට මේ දෙකේ බලය ගත්තොත් තියෙනවා මේ තියෙන දෙකේ බිඳුව වෙනි බලය. දෙකේ එක දෙකේ දෙක මේ ප්ලේස් එකට අදාළ වෙන දෙකේ බිඳුව. මේ ප්ලේස් එකට අදාළ දෙකේ එක පළවෙනි බලය. මෙහෙම දෙකේ 7 වෙනි බලය වෙනකම් මෙතෙන්ට යනකම් එනවා. දැන් මේක අපි සුළු කරන්න ඕනේ. We have to, right, up to this point, did you understand?
Yes, sir.
Right, so you must do the next one by yourself, right? Okay, we'll do some exercises. Now I will not do another one. We'll go to the workbook if we have time today and do some exercises there. Right now, here on 2 to the power 27, 2 to the power 7 equal to 128. This one. multiplied by 1. So if you multiply by any number by 1, that is going to be the same number. ඕනම සංඛ්‍යාවක් එකෙන් වැඩි කරොත් අපිට හම්බෙන්නේ ඒ සංඛ්‍යාව. Then plus this is going to be 0 plus 2 to the power 5 is going to be 32 plus you have to remember this, right? Otherwise you can't do the calculation quickly. 2 to the power 4 is 16 plus 2 to the power 3 is 8 plus 2 to the power 2 is 4 plus 0 plus 0. Now you can see, you can do the calculation now. 128 plus 32. I will omit the zeros. 16 plus 8 plus 4. So what I will do is I will add 8 to 32. So it will be 40. 40 to 56, it will be what will be 56? 56 and this. What is the value? So do the calculation, see. Did we get the same values?
One second, sir.
Check if you got the same values. So now you can simplify it. Let me take a part of. So when you multiply these values, so once you add 4 to 16, it will be 20, 20 plus 8, 28. Then 32, then 120. 28 plus 32 is going to be 60. Then 128. Then you get 60 plus 128. It will be 108. It is on the power 10.
Okay, sir. Thank you. Sorry for the confusion.
Okay, so next time you have to do this alone. So if you can't just do this calculation at once, try to do the calculation part by part. So, okay, write it down. Finished writing? Once you finish writing, please let me know.
Sir, done.
Yeah, oh, good. Right. So now we will move on to a new, not a new lesson, but we'll go to this next section of this. So you can see there are more examples. Please have a look at this. You can see this number, which is in binary. You can see the place values on top of it. It has been converted like this, and you can see the values here, and also this being added together, and you get 23 with the base 10. Again, you can see another value, which is converted in the same form, and you can see it is 18. So once you go through this book, you can find there are some examples. මේක දිහා දැන් මේ පොත බලාගෙන යන්න. එතකොට අපිට හම්බෙනවා examples ගොඩක්. Now we come to the next topic. Write down the topic binary representation of data. You can see the topic in the screen. Binary representation of data and instructions on computers. Write down under that. Write down under the particular write down under this particular topic. A topic යටතේ ලියන්න. Computers use on and off states. Computers use on and off states to represent data. On and off states to represent data. To represent data. to represent data inside it. So write down on and states are representing two signals. On and off states are representing two signals. On and off states are representing two signals. Then write down those two signals can be represented using ones, 1 and 0. Those two signals can be represented using ones and zeros. Those two signals can be represented using 1 and 0. So on means 1, off means 0. Write down this particular fact right down together. So after this statement that you have written, make a on means 1, off means 0. Right, on is 1, off is 0. So then write down after that right after whatever you wrote, write down. Then ලියාගත්තකට යටින් ලියන්න ඔය on කියන්නේ 1, off කියන්නේ 0 කියලා ලියාගත්තනේ ඒකට යටින් ලියන්න. Different data types. Different data types different data types such as numbers, text, sounds, numbers, text, sounds, and images. Numbers, text, sound, and images are stored in the computer memory. Are stored in the computer memory. Are stored in the computer memory as a pattern of bits. 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 Write down example. Write down this one right after what you wrote. ඔය ලියාගත්තකට යටින් මේක ලියාගන්න. 168. Right. Now write down below that. එකට යටින් ලියාගන්න. The above number. The above number is represented inside the computer the above number is represented inside the computer using the bit pattern one zero one zero 1000. The bit pattern.
Sir, could you repeat the sentence one more time?
The above number is represented inside the computer using the bit pattern write this. Using the bit pattern, then write this.
Thank you, sir.
Okay. So you can see how it is represented, and here you can see now in this diagram, every data, the data seen by humans, the data processed by humans is going to be represented using different bit patterns. So for example, if you take an image, the image is represented using a bit pattern that you can see in the right hand side. If you take a sound, you can also see again another bit pattern which is at the right hand side. Then you can see again, if you take letter A is also represented by a bit pattern like this inside the computer. So computer understands that this is the particular representation of letter A. So this is what computer understands, and this is what we understand. So we understand it as it is mapped to this bit pattern when it is stored inside the computer. And if you take number 9 is also stored in this bit pattern inside the computer. You can see number 9, to represent number 9, only these 4 bits will be enough, right? So if you just convert number 9 into binary, you have to keep on dividing number 9. So you get 4, there's 1 remainder, 2, 0 remainders, again 2, 1 remainder, so 0 remainder. So the value is 0, sorry, 1, 0, 0, 1. That you can see there. But in front of this, you can see additional 3 bits. Right. In front of this, you can see 3 additional bits. The reason for representing 3 additional bits, the reason for that is mainly we have to represent a chunk of bits inside the computer, and we cannot represent 4 individual bits. So just to represent a number, we have to take at least 7 bits or 8 bits. In this, we have the representation of numbers using 7 bits. There is a number එක then computer අපි මෙහෙම ලිව්වට computer එකට මේක මේව හතරකින් කරන්න බෑ යාට bits 7ක් හෝ 8ක් හෝ it needs about 7 or 8 bits in that case. එතකොට ඉතිරි bits ටික අපි පුරවන්න ඕනේ. So the rest of the bits we will be filling up with zeros. You will understand why we have to do that in the future, right? But at the moment, it is even not explained here, but you can see that there are 3 more bits in front of what? There are 3 bits in front of this. So there's a reason for that. So there's a reason why you have 3 bits in front of it, because bits, these numbers are why you represent. To fill up the rest of the bits, you have to complete it with zeros in front of it. That is why we must be representing more zeros at the front. So the value for the zeros is around the so that is some a fact that you can remember. So let's come back to this. So these are the different bit patterns that are naturally, these are actually samples, right? Actually, this is not the exact bit pattern that is used to represent this image. It's going to be a large series of bits. So the make a මේ image එක represent කරන්න use කරන bit pattern එක මේක නෙවෙයි. කියන්නේ bit pattern එකක් තියෙනවා. හැබැයි මේක නෙවෙයි. ඒක මෙතන එහෙම පෙන්වන්න බෑ. මෙතනත් එහෙමයි. Here's the same sound. You have a bit pattern, but this is not the exact bit pattern that represents a certain sound. Letters. Each letter is having a bit pattern, right? To represent. So I will show you some. If you take the bit patterns that are representing these letters, to show you that you can see here, you can see letter A. So inside the computer, each letter, each symbol has a one binary representation or digital representation of it. So here, for example, you can see A is represented by 1, then 1, 2, 3, 4, 5, 6 zeros. Sorry, 5 zeros and 1. Sorry, 1, 0, 0, 0, 0, 0, 1. That is the bit pattern for A. Check if it is the same. You can see that, right? බලන්න ඒකම තියෙන්නේ කියලා. 1, 5 zeros, 1. Here 1, 5 zeros. So again, if you take letter B, you can see it is again 1, 4 zeros, 1 0. Letter C, 1, 4 zeros, 1 1. So like that, you can see there are different codes for each and every letter. So we have discussed the next one also. Hence, the computer takes all inputs in binary form, process them in binary form, provides them to the output devices in the form of text, images, sounds, and videos. You can see that what happens over here. Every data item, or if you take keyboard, digital camera, microphone, everything is going to send the data as a bit pattern to the computer, and the computer is going to take the values and store it inside it in the memory. So here you can see these are the input devices, right? These input devices will be used to capture the data from different sources. So example, now digital camera is going to capture images. Keyboard, we are going to type something and send to the computer. Whenever these things are captured from these cameras or these input device, again, may digital camera එකෙන් හරි keyboard එකෙන් හරි මේ data capture කරොත් data මේ ගත්තොත් ඒ data ටික යන්නේ මේ විදියට. The data goes into the computer using this bit pattern. එතකොට data ටික computer එක ඇතුළට යන්නේ මෙහෙම bit pattern එකක් පාවිච්චි වෙලා. මේ bit pattern එක තමයි මේක ඇතුළට. So that bit pattern is going to be stored inside the memory. So the bit pattern එක මේ memory එක ඇතුළේ කියන්නේ computer. So you can see now this part is something about the internal structure of the computer. So මේ තියෙන්නේ computer එක ඇතුළේ තියෙන කොටස්. So one is main memory, the other one is microprocessor. The main memory is going to store the data of the computer in the form of these bits. So the main memory එක තියන් ඉන්නේ මේකේ තියෙන data ටික. එතකොට මේකට, so we call this a random access memory. So in Sinhala we call it සසම්භාවී ප්‍රවේශ මතකය. මේ සිංහලෙන් කියන්නේ සසම්භාවී ප්‍රවේශ මතකය කියලා. ඒකට අපි කියන්නේ random access memory. So the memory is the one that is storing the data temporarily until it is being processed in the microprocessor. Microprocessor එකේ මේ data process කරන්න කලින් මේ එවන data ඔක්කොම තියාගෙන ඉන්නේ memory එකේ. So even if you take yourself, if I tell you to add two numbers, first you take it to your head. So that means you have some memory. Then you process it with your processing power. So you may be adding them. Then again you can display it or you can just tell it from your mouth. So that is the output. So you are also like a computer. So you can grab the information that I give you. You will be storing it inside your memory. Then you will process it if you need, and then give the value through by writing or by your by verbally or by your mouth. You will speak, right? එතකොට දැන් අපි කම්පියුටර්ස් වගේ තමයි දැන් අපි ගත්තොත් මම කිව්වොත් එහෙම numbers දෙකක් add කරලා මට කියන්න කියලා. numbers දෙක එතකොට මම කටින් කිව්ව ගමන් ඕගොල්ලෝට ඒකේ memory එකට ඒ කියන්නේ තමන්ගේ මතකයට යනවා. මතකයට යන විදිය ගැන අපි කතා කරන්නේ because that's a human. So එතකොට මේ මතකය මොකද වෙන්නේ? පොඩි වෙලාවක් ඔළුවේ තියන් ඉන්නවා. හැබැයි but it's temporary. You can't, it's not necessarily permanent remember. So you will just remember it for maybe 5 or 6 seconds. So once you get it, එතකොට ඒක තප්පර 5ක් මතකෙ හිටියි. වැඩි වෙලා මතකෙ හිටින්නේ නැහැ. ඊට පස්සේ ඒක අපි මොකද කරන්නේ? process කරගන්න ඕනේ. ඒක එකතු කරලා අපි ඊළඟට ඒක දානවා monitor. So you can show it in the monitor. So you can see the digital camera, keyboard, all these things are going to capture the data and send it in these bit streams or bit patterns towards the computer. The computer's main memory is also going to store it as a bit pattern, and the microprocessor will be storing it, or microprocessor will be processing it with the same bit pattern, and it will just do some modifications to the bit pattern based on the output, and again it will be sent to the monitor, right? This is how it works. So you can see now all activities in the computer, such as data input from the input devices, saving data temporarily in the main memory, and saving permanently in the hard disk. Processing data and sending processed data to the output device are carried out using zeros and ones. Okay, so that's the one thing that you have to remember. So here we will write note on this one. Okay, so write down a smaller note on this. Put a note there, ලියන්න පටන් ගන්න යටින්. Write down the data accepted by computer. The data accepted by computer will be converted to a bit pattern. The data accepted by computer will be converted to a bit pattern. Right, full stop. Then it will be stored. Let's see the note here. Then it will be stored in the computer's main memory. Inside brackets, put temporarily. Right, you can complete the note. Then the CPU understands the data represented by these bit patterns and processes it. Then again, data will be output through the output devices. So you should remember that when we enter the data, that is converted to bit patterns. Finish writing.
Done, sir.
Okay. Other two.
Done, sir.
Leandra.
Sir, can you give me a minute?
Okay, you can look at the screen and write it, complete it.
Done, sir.
Right. Okay. Now, so now this lesson is over actually. So what you should understand from this lesson is what? Okay, now I'm asking you, what did you understand from this lesson? Yes. So after the lesson, you should know what is the learning outcome. Outcome of the outcome of learning this lesson. මේ lesson එක ඉවර වුණාට පස්සේ lesson එකෙන් අන්තිමට අපිට ලැබිච්ච දෙයක් තියෙනවා. ඒක දැනගන්න ඕනේ. That you have to every lesson, I mean not in IT, mathematics, science, whatever it is, you should be knowing what is the outcome. So you have learned something now. Why did you learn it? Can someone tell me? I make it අපි ඉගෙන ගත්තේ. The reason for learning this, can you tell me?
To figure out what is the method that is used to represent the number.
You are correct. There's one more thing to be added. So the method of representing not numbers, the method of representing data inside the computer. That's what we have to study. So that's what we are intended to study. So ultimately, first we discuss about number systems. Then we discuss about how we convert the numbers from decimal to binary, and also in the other way around. And then we discussed how the data is represented inside the computer, and we came to know that all the data is represented using bit patterns, and we actually observed, or we just experienced that the numbers are directly, once you convert it to binary, then that is the actual representation of that number inside the computer. So if you look at your note, you can see that 168, when you represent it in the inside the computer, it's going to be 10101000. That's it. Okay, that's what we have to learn. That means mainly in this lesson, we have to learn how the data is represented inside the computer. Is that clear?
Yes.
Okay,
Yes, sir.
so that is what we are learning in this lesson. So not about numbers, right? Numbers we are learning as a background information or as some necessary information to understand the main thing. Main thing is representation of data, right? So that is why I learned about number systems. So our lesson is over. There are more things to do. So now we come to the workbook. So I sent the workbook also to you. So this is the workbook that we have. Right now, all of you, can you start the activity 1.1 and tell me what you are getting for these things when I'm so I will give you about few minutes, right? Maybe about 3 minutes or 4 minutes to do this. Now do it and tell me the answers when I ask you. So don't tell me the answers until I ask you, right?
Sir, sir, Sir,
Yes, what are the answers? A number system is using 10 symbols. Can you see that?
yes, sir.
A number system is using 10 symbols is a, what is it?
Decimal number system.
Right, that's good. Decimal number system. Then the base for this 100 110 is what?
10.
Sorry, what is the answer?
10.
10. Good. So answer is 10 here. Okay, so we can just write the answers here. This one, decimal. This is 10. Then the number system using what?
2 symbols.
Right. 2 symbols is called is a
Binary number system.
binary. Good. The number of symbols in a number system is its what? That is easy now. You have only one left out of this. What is
Word list.
not word list? These are the, I mean, word list mean these are the words that you had used for filling it out.
Yes.
Yes, base. Right. පාදේ කියලා අපි කියනවා. එතකොට මේක binary, මේක 2, මේක 10. Then we come to next one. Expand the decimal numbers given below. Right. Write down 528 and try to expand it. Do you remember to expand it? How do we expand it? How to expand it? Okay, I will do a one for you. First one is 528. 528 with the base 10. So first of all, what you should know is this is having 10 to the power 2 place value, 10 to the power 1 place value, 10 to the power 0 place value. These are the place values that we have. 10 to the power 2, 10 to the power 1, 10 to the power 0. Now, here you can see this means 5 multiplied by 10 to the power 2. Or you can write the other way around, plus 2 multiplied by 10 to the power 1 plus 10, so 8 multiplied by 10 to the power 0. So this means 5 into 100 plus 2 into 10 plus 8 into 1. That means 500 plus 20 plus 8 will be 528, the base 10. That's it. So now we have 2 more things. Okay, write this down. That is the answer for activity 1.2, part A. Finish writing.
Yes.
Right.
Done, sir.
Done. Right now, by yourself, you have to do this. 186 and 308. Do the conversions.
So sorry.
Do these two conversions. Can you see the screen now? 108. So you have to do the B part and you have to do the C part of this.
Okay, sir.
So we have to complete those activities and proceed. Hundred 186 and 308.
Done, sir.
Then we'll see how to do that. 10 to the power 0, 10 to the power 1, 10 to the power 2. So it's going to be like 6 into 10 to the power 0 plus 8 into 10 to the power 1 plus 10 to the power 1 into 10 to the power 2. That means this is 100 plus 80 plus 6 altogether. That means 186. So it's all not about IT, it's all about mathematics. So just do it. Right? Nothing about ICT there. Okay.
Done, sir.
Done. Okay. Then 308, last one. So please complete this before we proceed to the next one.
Done, sir.
Last one.
Done, sir.
Right. Let's go for the last one. Three hundred eight. 308 This one is going to be 8 into 10 to the power 0 plus 0 into 10 to the power 1 plus 3 into 10 to the power 2. So altogether it will be, this is 300 plus 0 plus 8, 308. So I'm a bit faster now because you should be doing it much faster in the oncoming days, because one thing you should do is improve your speed. Speed එක වැඩි කරගන්න ඕනේ. හැමතින්ම නැත්තම් කරගන්න බෑ. So you must try to speed up everything. Okay, so you can see more exercises here. Exercise out here. So let's observe more exercises over here. So you can see one FP 1.3. So I have sent you this. PDF if you can't take it from the chat, let me know. So I will put it to the chat again. You can see now, convert the following decimal numbers to binary, and also convert this to decimal. And also you can see here, we can see some numbers given here, and also you can see you have to put these numbers inside these circles. So these are the 3 activities, and you have to put these activities inside these circles by reading it carefully. Okay, so today I'll be stopping the lesson now, and next day we can start the new lesson. It's all about configuring and formatting a computer. Okay, so please go through what I have done. So we have finished the first lesson. Do the exercises in the activities in the with regards to this first lesson and complete it. So we'll stop now, and good night to all of you.